we're moving on to similarity. Similar polygons are polygons that have the same shape but not necessarily the same size. Okay, so they give us here two similar triangles as an example. Okay, and so their corresponding angles, what they say here, for example, angle A is congruent to angle D. So that means that they're the same. So these two angles are equal in measure. Angle B is the same as angle E. Whoops. So there's angle B and angle E, and then last angle C is congruent to angle F. So in your congruent polygons, the angles are going to be congruent, meaning that they're going to be equal. Now their sides are not equal, their sides are proportional. So what that means is if you're to take A over B and divide it by D over E, so A over B divided by D over E, 6 divided by 3 gives us 2. B over C, BC, and EF, when you divide them, 9 over 4.5, that also gives you 2. And then CA and FD, so CA 10 and FD is 5. And when you do 10 divided by 5, that gives you 2. So that gives you all the proportions. So similarity ratio is a ratio of the lengths of the corresponding sides. The similarity ratio of ABC to DEF is 2. Okay, so the similarity ratio is a little bit different than your scale factor. Your scale factor, you would divide them the other way around, where you would take the smaller triangle and divide it by the bigger triangle. And so similarity ratio is going to go the first one that they tell you. So for example, ABC, you're going to divide that by DEF. So I just don't want you guys to get confused about that. But here it says identify the pairs of congruent angles and corresponding sides. So we're just identifying. So here, angle J has one little arc mark, and then so does angle M. So that means angle J is similar to angle M. On here, angle L has two little arc marks, and so does angle P. So angle K, angle L goes with angle P. Okay. So then in that case, if angle P and angle L go together, then that means that angle K is going to have to go with angle M. Okay. And then from there, when we write this one, now the order matters with this one. So here it is telling us JK, so from J to K. Okay, so from the pink angle to the blue angle. So I do the same thing here. From the pink angle to the blue angle would be M to N. Okay, so if you notice here, J, here's J, and it goes to K, and then here's K. Okay, so then that means that J is the same as M, so that's why it's first, and then K is the same as N, so K and N goes second. Okay, so the order does matter with these ones. All right, next we have KL. Okay, so KL is K goes from the blue angle to the purple angle, KL. Okay, so we're going to go from the blue angle to the purple angle would be N to P. All right, and then last we have LJ. So L goes from the purple angle to the pink angle, so LJ. So here we would go PM. Okay, now you don't have to color code this, but you just need to make sure that you match the angles up. So we know that L and P are the same, so that's why we had to put P first. And then we know that J and M are the same, so that's why we had to put J second. Okay, so you have to match up their positions. All right, the next one, number 2. So here they say angle A. Angle A has two little arc marks here, so angle A is going to be the same as angle Q. Okay, so if I'm looking here when I'm comparing, since A is the same as Q, I already know that right here there's going to be a Q, and right here there's going to be a Q. Okay, then next I have angle B. So angle B here is the bottom right angle. So here is my bottom right angle, which is the same as angle R. Okay, so then from this information, I see a B here. That means that this is going to be R. I see a B here. That means this one's going to be R. All right, moving to the next one. Angle C. So angle C is the top right angle. So angle C here is the top right angle. Would go with angle S. Okay. So if C is the same as S, then that means there should be an S here, and then there's a C here as well, so that means there needs to be an S there. Okay, because C and S are corresponding. And then last here we have angle D. So angle D has one big arc here, so that goes with angle T. Okay, those are congruent. So then where I see a D, I see a D here, that's T. I see a D here, this is T. Okay, so just to double check real quick. They tell us from A to B, so here's A to B. Okay, it goes from the pink to the purple angle, so this one should go QR. Okay, then we have B to C. So from B to C, where's B? B to C is this side here, so B to C and R S. Okay, which is what I wrote there. And then the next one we have C to D, so this is C to D, which would go S to T, which is what we wrote here. And then last from D to A, so D to A would go from top to bottom, T to Q, top to bottom, and that's what I wrote here, T to Q. Okay, so either way, if you go by the letters, you go by the diagram, as long as you match them up by their congruent angles. Okay, here it says determine whether the polygons are similar. If so, write the similarity ratio and the similarity statement. Okay, so the way that we're going to be able to tell if they're similar is if all of their angles are congruent. So here they tell us that these two angles are congruent by using the little arc mark. Okay, then they tell us that this is 101 and it is congruent to this one over here. Okay, so using the third angle theorem, if two angles in a triangle are congruent, then that means that the third angle also has to be congruent. Okay, so are the triangles similar? Yes, because we can identify from the diagram that all the angles are the same. If yes, write the similarity ratio. Okay, so the similarity ratio, when we're comparing, we're going to take one of the sides. So say I'm taking from F to G, that's going to be the same. I'm going purple to pink. This one's going to be the same, purple to pink. Okay, so it's going to be 12 over 18. That's my similarity ratio. If I reduce that, that reduces to 2/3. So here I'm going to write 2/3. And then it says, and the similarity statement is. So your similarity statement is when you do something like triangle, blah, 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 is similar to triangle, blah, blah, blah. Okay, so on this one, we have E, F, G. So E, F, G. Okay, so triangle EFG is similar to, when you write the similarity statement, you do have to match up the angles. So since I wrote E first, then that means I have to write H first because E and H are similar. And then I put F, so if I wrote F next and then the letter J goes next because F goes with J. And then G was the last letter I wrote, and angle G is similar to angle K. So then that's the way you need to write your similarity statement. And that's it. All right. The next one, CDE and LMN. So here we have, let's see, they're asking if the triangles are similar. So this time they don't give us the angles, so the way that we tell is by checking the similarity ratio, okay? And if they're similar, then their similarity ratio should be the same. So here I have 2 and I have 2.3. So I'm going to do 2 over 2.3. And it's going to give me a number. I'll go ahead and write the number down in just a moment. Here I have from D to C would be N to L. So we have 1.5 over 1.7. And then last I have from L to M and C to E. Those are similar ones. So because I started with the first one, I'm going to put 1.4 on top and 1.6 on the bottom. Okay, so if these are similar, then it's all going to give me the same decimal. So I am going to put this in my calculator. 1 second. So 2 divided by 2.3 gives us 0.869. Okay. And then when I do 1.5 divided by 1.7, this gives me 0.882. And 1.4 divided by 1.6 is 0.875. Okay, so none of these numbers are the same. Okay, even though they're close, they're not the same. So are the triangles similar? No. If yes, write the similarity ratio. Well, they don't have a common similarity ratio, which is why they're not similar. And the similarity statement is we can't write one because they're not similar. Okay, the next one says use proportions to solve the following problem. So triangle ABC is similar to triangle DEF. What is the length of AC? Okay, so they're already telling us that they are similar. So all we gotta do is, if we're looking for the length of AC, I'm gonna go ahead and put an X here for AC. And so this goes with this. Okay, so AC goes with DF. Okay, so we're gonna do X over 30 equals, and then we pick any of the sides because they give us all of the other sides. We can choose whichever one we want. So 20 and 50. So we put the smaller triangle first and the bigger triangle on the bottom. All right, so we go ahead and cross multiply. So we multiply X times 50, which gives us 50X. We multiply 30 times 20, which gives us 600. To solve for X, we divide by 50. And we get X equals 12. And so since they're asking us for the length of AC, that means that AC equals 12. And they didn't give us any units. Okay, the next one, it tells you EFGH is similar to JKLM. What is the value of X? Okay, so if we look here, they give us this piece right here, which is from G to H. So that means G to H, based off of the similarity statement, is the same as LM. So these two are the same. So I'm going to write 2x plus 1.5 divided by 18. Okay, and then if I look on this one, they give us this one as X. Okay, they didn't write anything here. They left that blank. They didn't write anything here. They left that blank. So that's why I'm not using those sides. Okay, so from F to E, that is the same as KJ. So here's KJ. So those are the two numbers that I'm going to use. I use the smaller one first. So it's going to be X on top, and on the bottom it's going to go the 8. Okay, so then from there, we're ready to cross multiply. So we take the 8 and we multiply it times the 2x plus 1.5. So not only do we have to multiply it times the 2x, which gives you 16x, we also have to multiply it times the 1.5, which gives us 12 equals. We take the 18 and we move it to the top, so it is equal to 18x. Okay, then we're going to go ahead and solve for x. So I'm going to go ahead and move over this x on the other side with the 18x by subtracting it. And we get 12 equals 2x. Then we divide both sides by 2. And we get x equals 6. The question is asking us what is the value of x, so we're done here. They're not asking us to find one of the sides or plug it in. They're just asking for x. All right, the next one, triangle proportionality theorem. So if a line is parallel to the side of a triangle, intersects the other two sides, and it divides those sides proportionally. Okay, so it kind of makes a little bit more sense when we actually try the problem. So if we see that this is cutting the two sides into two parts right here at R and S, and it's parallel to one of the sides, then that means that this is proportion. So that means that we have this 12 here. We can divide it by this side right here. We don't know what it is. I'm going to go ahead and call it x. So 12 over x equals, and then this side we have 6 on top over 7. So that's how you set up your proportion. Okay, so we're going to go ahead and cross multiply. So 12 times 7 gives me 84 equals 6x. We divide both sides by 6, and we get, let me see, 14 equals x. Okay, and they're asking us to find the length of RQ. Well, RQ, that's what I had put as an x there. So that means RQ equals 14. Okay, let's go ahead and look at the next one. So here they want us to find the length of JN. I'm going to go ahead and write an x there. So on this side, because we have these two sides are parallel, then that means that this piece here, 20, over the second piece, 16, is equal to, and then we have to go in this direction, 38 over x. Okay. And so they're directly proportional. So we're going to go ahead and cross multiply. So the x is going to move up and the 16 is going to move up to multiply. So 20 times x is 20x, and 16 times 38 is 608. Then to solve for x, we're going to go ahead and divide both sides by 20. And we get x equals 30.4. Okay, so this x is equal to 30.4, so that means from j to n is equal to 30.4, which is what they're asking us for. And that's it. Thank you guys. We'll see you guys next time. Bye.